Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper from the Hugging Face trending list, published on November 17th, 2025, just yesterday. It shows that a simple weighted averaging trick called soup of category experts can push existing large language models to state-of-the-art on the Berkeley function calling leaderboard, reaching 80.68% accuracy for 70 billion parameter models without any expensive retraining. The paper is titled Supermodel: How Simple Arithmetic Unlocks State-of-the-Art LLM Performance. And, as we see later, the implications for low-cost model upgrading are pretty significant. Also, the authors shared an open-source implementation on GitHub. There you'll find the full souping framework, end-to-end scripts to download llama-based checkpoints, average their weights, and save new ensembles, plus GPU-accelerated averaging utilities, parallel runners, and editable configuration files for custom 8B and 70B model soups. Figure 1 shows that different function calling categories on the Berkeley leaderboard do not move in lockstep, which is exactly what Soup of Category Experts takes advantage of. This heat map plots how strongly model scores in one category correlate with scores in another, using darker green for stronger positive correlation. The central block of dark squares reveals a tight cluster of multi-turn tasks, so models that do well on one multi-turn variant usually excel on the others. In contrast, the lighter band near the irrelevance and relevance detection corners suggests those skills behave more independently, which creates room for specialized expert models to shine. Figure Table 1 makes the payoff very concrete, showing that the Soup of Category Expert soups actually beat every individual model on the Berkeley function calling leaderboard. The table lists both 70 billion and 8 billion parameter families, and in each block, the bottom row with Soup of Category Experts has the best accuracy. Even simple uniform souping helps a bit, but strategic model selection plus optimized weights pushes accuracy several points higher. This means that careful arithmetic over existing checkpoints rivals or surpasses far more expensive custom training runs. Table 2 shows that this weighted souping idea also boosts performance on a multilingual grade school math benchmark, which tests word problems in many languages rather than tool calling. The individual MetaMath Octopus Mapo model reaches about 51% accuracy, but plain uniform souping of all four math models actually drops to 47% because weaker models dilute the mix. Once Soup of Category Experts selects better ingredients and tunes weights, the final soup climbs to about 52%, clearly beating every single component model. Alright, this part of Table 2 shows that even on the long context infinity bench test, careful souping squeezes out extra accuracy. The 5 Llama 3 candidates all sit around 27%, and plain uniform soup does not move that needle. Once the method first selects a better subset and then tunes the weights, accuracy rises to about 28%, which is a small but consistent gain for essentially free arithmetic. Figure 2 shows that after souping, performance across task categories becomes much more tightly linked. Each panel plots a Pearson correlation matrix, which measures how strongly scores in one category rise or fall, together with scores in another across many checkpoints. The top row corresponds to raw, unsouped models, while the bottom row shows the same checkpoints after forming soups. In the BFCL and MGSM panels, pale scattered blocks shrink into darker, more uniform squares, so strengths and weaknesses align more consistently across categories. Even on the smaller infinity bench panel, the post-soup grid darkens noticeably, indicating a more coherent capability profile. Figure 3 shows how the Soup of Category Experts method pinpoints which math models really matter for different languages. The left heat map highlights that Spanish to English and Chinese to English behave differently from the other multilingual grade school math categories, so they invite separate experts. On the right, the table and Shapley-value bars, where a Shapley-value measures how much a model boosts any team it joins, single out models M1 and M2 as the key contributors, especially when paired together, while M4 contributes very little. So, the big picture is that Soup of Category Experts turns cheap arithmetic over existing checkpoints into real gains, delivering state-of-the-art function calling and steady boosts in math, multilingual, and long context tasks. The broader implication is exciting. Future model upgrades might rely less on retraining and more on smart recombination. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.